Hi, welcome back to my YouTube channel. In this video we're gonna see how we should solve the Gaussian integral, which is one of the most confusing integrals in the field of mathematics, and it's used a lot in the field of statistics and quantum mechanics. And this integral does not have an elementary antiderivative form. We cannot use substitution or integration by parts to solve this integral. Instead, we should do a little bit of analysis in order to solve this integral. Well, the graph of this integral looks something like this, and we want to find the area under this graph because integral is all about finding the area under the graph. So the thing is that the integral, because this is an even function, we can say that the integral from 0 to infinity, we're gonna find this integral that I'm gonna shade it with red here and just multiply it by 2 to get the whole area here. This is a property of even functions. So we're gonna say e to the negative x squared dx, and we're gonna define another function also to be e to the negative y squared dy. We want to use a smart trick here to manipulate the algebraic notations of this integral and see how we can get a better result for that. So what I can do, I can multiply these two integrals together, which is going to result in I squared, and it's going to get 4 times, this is going to become a double integral, and when the powers are multiplied to each other, because the bases are same, they're gonna add up together and make this thing here. Now what I can do, I can say y equals xt, and if I take the differential of the both sides, dy is gonna be dxt. If I do this substitution here, I squared is gonna become these double integrals, and e to the negative x squared 1 plus t squared multiplied by dx, and this is important, by x and dt. So this goes to here, and dt goes with this other integral that is behind the back here. So we're gonna so this thing is gonna make our work easier, because this x e to the power of negative x squared does have an antiderivative. So its antiderivative, if you take the integral of it, it's going to be negative 1 divided by 2 times 1 plus t squared multiplied by e to the power of negative x squared times 1 plus t squared from 0 to infinity, and we're differentiating with respect to t. So I squared is going to be 4 times 0 to infinity. If I calculate this bound using limits, it's going to be e to the negative infinity minus e to the 0. E to the negative infinity, e to the negative very large number, is going to be 0, and e to the 0 is going to be 1. So this is going to be negative 1, and if we multiply it, it's going to become 1 divided by 2 times 1 plus t squared dt. The half is the constant. I can pull it out this integral, and this is going to become 2 times 0 to infinity of 1 over 1 plus t squared dt. This is the integral of arctan of t. So I squared is 2 arctan of t from 0 to infinity. If I calculate this limit, it's going to become arctan of infinity minus arctan of 0. Limit as t approaches infinity of arctan of t is pi over 2. So I squared is 2 times pi over 2. And arctan of 0 is just 0. I squared is pi, and I equals square root of pi. Wow, we got an interesting result here. Therefore, I can say that let me create a new space here. The integral that we were first trying to solve here is from negative infinity to infinity of e to the negative x squared with respect to x is square root of pi, which is a neat result. And you might have known the answer, that is root pi, but you might have wondered where the pi comes from. And this is exactly where the square root of pi comes into the play for our integration here. This might have seemed pretty monster integral to solve, but with this separation of bounds here and some change in variable, it was obliterated by our methods. So hope you enjoyed this video. If you have any questions, please let me know in the comments, and I'll see you in the next videos.